My name is Haley Rader, and I am one of the fellows with I-CCEW, and I also have the privilege of leading this semester's oil and gas team. So many of you probably know the oil and gas track is our newest track, and so it has not been without its challenges this semester. But I have been very lucky to have three very hardworking guys on my team who have used their prior knowledge and stick-with-itness to ensure that we have a quality outcome for our client. And I really couldn't think of a simple statement that would encapsulate everything that they've put into this semester, so I decided to write them a poem. And it's an acrostic for the word Petra, which is the software you'll hear more about that they use to analyze the data. So Petra, P stands for pals. I think we've become pals. E is for engineers, because they're engineers. T stands for the 13th floor of Sarkis, where they spent a lot of their time completing this project because that's where the computer lab is that has access to Petra. R stands for rocks, because they rock and they study rocks. And then A stands for absolutely grateful for this experience. I would like to thank RKI Energy for the project and then providing the data that we needed to complete it, specifically Ronnie Arani and then Cody Griffin, who really helped guide us through this process. So without further ado, let's welcome the team.
Hello, everyone. We're the Oil and Gas Exploration Team. I'm Dean Goodrich.
I'm Eddie Alfaro.
And I'm Kendall Prather.
This semester, we've been working very closely with our namesake, Ronnie Arani, and his company, RKI Energy Resources, to evaluate a formation that has not been historically produced. In doing this, it necessitated that we find pieces of rock that have been cut out during the drilling process called cores and cuttings. This was necessary because we have essentially no idea what is down there, and this will help us to gain a better idea of the formation properties. In doing this, we were given a 16,000 square mile area that we analyzed over 800 wells from. With these 800 wells, we used Petra to determine the thickness of the formation, as well as the tops and bottoms, to find where we would need to be finding these cores at. We were able to find 6 cuttings and 1 core in the formation that we will be going to Houston next week in order to conduct testing on to determine the hydrocarbon potential in the zone. We also were able to evaluate an area of interest that we developed from our ISOPAC maps. Now I'm going to be passing it off to Eddie, who's going to talk some more about cores and maps.
To identify a zone of interest within an area of study, we used 3 datasets. These datasets consisted of cuttings, which are fragments of the formation that are extracted when drilling. We also use core samples, which are cylindrical samples of rocks that are extracted from the formation. These 2 datasets give us information on the formation, telling us if there is oil or gas in the formation. They also tell us properties of the formation about its permeability and its porosity. This information give us an insight on how much volume of oil the formation can hold and how fast we can extract it. The 3rd dataset that we used was well logs, and this is information that we take with tools, run through the borehole, and this information gives us a characteristic signature of the formation, which can be used throughout the whole area on wells that drill through the formation. Compiling all this information, we were able to develop maps of the formation and gain insights on the structure of the formation. We found out that the formation goes from 2,000 to 20,000 deep from north to south. We also found out that at similar depth ranges, the formation goes from northeast to southwest. And we found out that from the 5,000 feet mark, the formation starts to steepen, which is a characteristic that can tell us the development of natural fractures in the formation in order to generate more oil, to extract more oil from the ground. From all these insights, we developed an area of interest which can be seen from the box out area in the map behind me. Now I will be passing it on to Kendall, who will be talking more about this target area and the cores that we found out.
So from structural maps, we were able to generate ice pack maps. And using these ice pack maps, we were able to determine the thickness intervals of the formation. The thickness across the entire study area ranges from 30 to 620 feet. And in our hypothesized area, the thickness ranges from 50 to 450 feet with an average of 300 feet. And then once we had obtained the thickness interval for our target formation, we were able to identify 7 samples that penetrated it across the entire study area. And of these 7 samples, we identified 1 core totaling 2,595 feet and 6 cutting samples across 6 different counties. With these samples, hydrocarbon presence can be determined through pyrolysis testing. And to recap our project, we have picked formation tops from over 800 wells across our entire study area and generated structural and ice pack maps from these formation tops. And with these maps, we were able to locate and acquire 7 core and cutting samples with which we will perform pyrolysis testing on. Once testing is completed, we will gather our results from our project and hand them over to RKI. They will analyze our findings and internally decide whether it is viable to develop the target formation or not. And we have thoroughly enjoyed working on this project throughout the duration of this semester. Unfortunately, due to the confidential nature of this project, we are unable to answer any questions right now. However, we are happy to discuss the project in more detail once the other presentations are completed. Thank you.